Okay guys, welcome to the Genome2D tutorial. It's my first tutorial, so hopefully I do a good job. It's up for you to judge. Any feedback is welcome. Okay, we'll start with the clean slate and create our first Genome2D project. So let's start. We are going to create an ActionScript project. Let's name it Genome2D tutorials. Hopefully there will be additional videos, so we'll start from this project even in later videos. We are going to run in web. Next thing we need is the Genome2D itself, so let's create a folder for our swig files. Let's download the Genome2D from build-genome2d.com nightlies, because we are going to use the latest nightly, not the official release, because it's quite old. I know I should do additional the official release of the latest genome, but there is no time for that or all the stuff around it. So let's download the latest nightly. We are going to copy it to upper lip. I'll do that in other windows. So okay, it's there. So let's start. First thing we need is our config. This is class that okay, I forgot to add the swig file to the compiler, so let's add that as well. Okay. Just to let you know, this is total improvisation on my part, so excuse any mishaps that may happen. Okay, we have our config. First parameter we need is the rectangle, because we need to specify the area for the back buffer for stage 3D where to render. So let's do that. I'll go with the whole area, so it's 0, 0 to stage width and height. On mobile you want to use, especially if you are going to use full screen or do a full screen application, you'll probably use a stage full screen stage width and height, because these stage width and stage height parameters may change multiple times during startup on mobile, and it's kind of a mess. The second parameter is profile. There are currently two profiles, baseline and baseline constraint. More are coming from the upcoming versions of stage 3D. Anyway, baseline constraint is a little limited profile, but it's good enough for 99% of things we want to do, so I'll leave it there. It supports more GPUs, so it's widely spread. Anyway, next thing we need to do is add a listener to genome initialization, so we know when it initialized. As you can see, genome uses signals instead of events, just for performance reasons and because I like it, because I'm from C++ background and this is more up my alley. Anyway, Genome2D initialized. Okay, I kind of messed it here. Now let's create our function for the callback. Genome2D initialized. There are no parameters for this callback, and I used add once instead of add. For anyone familiar with signals, this means that this will only listen once for such event or callback, and if there are multiple initialization Okay, I missed that one. Initializations, it will only fire for the first one. Anyway, now we can initialize the genome framework. We need a stage reference and a reference for the config. There are more parameters we can specify in the config. I'm not going to talk about them now, but most of them we can even change during when Genome2D is running. So we can, it's kind of in settings, if you will. Yeah, configurations. Because many people ask if configurations are like predefined and they can't change later. Some of them can, most of them can, some of them can for obvious reasons. We'll delve into that topic later. You can access the config later at any time using Genome2D get instance config if you want. Anyway, now we have our genome initialized. Let's try it out. Okay, one more thing. I will disable the HTML wrapper because I want to run it standalone. And also I don't have the latest player even if I am using the latest SDK. So we'll just use the 11.4 player which I have installed. It's a laziness on my part. Anyway, let's start. Okay, as you can see, the genome is initialized successfully. If we wanted to listen on something else, like for some reason it will not initialize, like the GPU isn't supported, or there is no direct V mode or stuff like that, we can listen if it failed. Although if the GPU isn't supported, it will probably initialize anyway, but in the software mode. That will go run probably too slow, so you'll notice anyway. So now when we have our framework initialized, we need to render something, probably all of you are expecting, so we'll see something. So I will go to add some assets here for us to render. Okay, I will copy them from somewhere. Let's use these. Oops. Now we are not going to load them externally just because it's a lot of work and we don't want to waste time here. So I'm going to embed them. I'm sure all of you are familiar with embedding stuff. So it's pretty straightforward. Create GFX class. Now we have this image embedded and we can reference and create it using this class. So since we can't render bitmaps directly in GPU, we need to upload them to the GPU first as a texture. So first thing we'll do is use a factory method in Genome2D to create a texture from our bitmap. The most obvious, well, there are more factory methods to use. I will go into them later. The most obvious one for now is create from asset. First we need to specify an ID for the texture and the asset class to create from. In Genome, all textures need to have unique IDs because textures are uploaded to the GPU and stay there unless you dispose them, and this is kind of like in a library, to know that we have something there. That's why I went with the IDs. So keep that in mind, because it will throw you an error that the texture with such ID already exists. You can access the texture at any time on the GPU using this ID. That's why you don't need to store a reference if you don't want to. You can, but you don't need to. So if you want to create another create texture with that ID later, you will need to dispose the first one before you create the second one, otherwise you will run into an error. Anyway, now we have this texture, create texture, and we need to render it. To render stuff in Genome, you can either use the low level calls to render directly to the back buffer, or you can go through the render graph, which is like the display list or similar to the display list, although Genome uses the component method architecture, not the inheritance architecture. So there are nodes which specify where something is. It's the hierarchy, and then each node can have a component that do stuff. For example, sprite component, which we are going to use, is a component that renders a single texture. So let's create a node with the sprite component. Again, we are going to use factory method. Create node with component. Easy. Now we can specify the texture for the sprite to render. As you can see, we can use the texture ID because it's unique, and the create will always refer to this texture we created. If we wanted to save a little bit of performance, if we run this like thousands of times, we can store the reference to the texture like this. And this stores to the direct reference to the create texture. And instead of using texture ID, we could use sprite set texture to set the texture directly. What this does is actually look up for this create texture inside the Genome texture library and assign it. So it's the exact same thing, but we are going around the lookup if we are setting this texture directly. Anyway, I'm going to use the IDs for simplicity. Now we want to add this node with this sprite to the render graph so we can see it, obviously. There is a root for root node of the render graph where we need to add our stuff. So we are going to access it using the singleton Genome2D method and root. Now we are going to use the pretty familiar method add child. We can't add the sprite directly because sprite is a component, it's not the node. But since sprite is a component on a particular node, it keeps the reference to that node. So sprite node. And now we can run this little example and let's see. Okay, as we can see, there is our crate. It's at 0, 0 because we didn't set the positions explicitly. So let's change that. To change positions in Genome2D, there is a component to do that as well, because nodes don't hold transformations. Since they don't hold rendering, they don't hold anything. Those are just abstract instances that encapsulate other nodes for the hierarchy itself, but they don't keep anything else. But there is a component on each node that is created by Genome2D, and it's the transform component. So each node has this component already. You don't need to create it. It's similar to how Unity does things. So, and this transform component keeps all the information about transforms, like visibility, alpha, rotation, translation, and stuff. So we can set the position using these setter methods for x and y, like 400 and 300. Okay. Now, as we can see, we change the position of our crate. There are also multiple helper methods to speed things up, like set position. We can use this method. It's the same thing. This will be faster. Instead of using two setters, we are using just one call. We can also change the rotation. As you can see, the rotation is in radians and not the standard degrees, because radians are I mean, I'm more familiar with radians, and they're faster to work with. All the math methods work with radians. So some people have problem with readability of radians, but there is no problem with calculating them to degrees and back anyway. So all the components, all the transformations in Genome, if you see some kind of rotation, is always in radians. Next, we can change the alpha, or red, blue, green. We can use these helper method instead of using transform.red and stuff. So let's change this so it will only have the red channel. And last, we can change the scale, again using a helper method instead of setters. I know this is simple stuff, I'm just putting out there so people are not familiar with this, even though I hardly believe there are people not familiar with this. We'll get a starting point. So let's try something different. Let's say you want to create a texture from some kind of bitmap data instead of an embedded asset, or you don't have the asset embedded, but you are loading it. So there is a factory method for that as well. Create from bitmap data. Okay, so I'm not going to load the asset or create some kind of new bitmap data. I will just reuse the asset. So we have this asset there, which is a bitmap. So we want to use the bitmap data of that bitmap to create a texture. Okay, something didn't run for some reason. Oh, I know, I misspelled the ID. Anyway, so it's there. Let's put it in the middle. so we can see our cute little crate. It's there. So you can create some kind of procedural texture and use it on CPU and upload it through bitmap data. You can also use other methods, for example byte array, because byte arrays are faster in some cases. They also upload faster to the GPU. There is also color, so for simplicity we want to create simple color textures fast. So let's say we want white texture, and let's specify its size. Now we'll see just a white rectangle. Now there is also ATF, create from ATF, which is a compressed format. I don't have any ATF files at the moment, so I'm not going to try it out, but people that are interested in it will know what I'm talking about. So the support is there for ATF as well. And last but not least is a render texture. It's a special texture that's used to as a target for the renderer. So we can render to a texture instead of to the back buffer or to the screen directly. This is used in post-processing stuff or pre-caching stuff or stuff like that. I'm not going into that at the moment. We'll probably return to that in other tutorial. Anyway, let's get back to our crate. Now let's scale it up to show something. Let's say 5.5. As you can see, the texture is pixelated. This is because by default Genome2D uses nearest filtering on the GPU shader, so it will not interpolate the pixels inside the texture when rendering. So to change this, if you want a nice smooth texture, we need to change the filtering time for a texture. So we can do this globally, which is my preferred method because I rarely need textures. Some textures using nearest filtering and some textures using linear filtering. So to set it up globally, we can do it pretty much anywhere. Let's do it here. We are going to access a static property in texture base class, and as you can see there are all these default properties that will that are used as a default value for once a texture is created. So let's say we want all the textures that are being created from this time on using linear interpolation. We simply set it up like this. If we did this after we created this texture would use nearest interpolation, because this just sets the global flag for all textures to create with that default filtering type, but it will not change filtering type of already created textures. Just so let you know, because some people asked me this on forum. Anyway, let's run our scaled up crate. As you can see, it's smooth, no pixelization, it's all nice. So most people prefer this over the pixelated rendering, because I don't know why. It's I like the old school, so that's why I chose the nearest filtering as a default one. I may change this later. Anyway, another option how to change this is to change it per texture basis. So we will store the texture reference of our crate, and now we can change the texture filtering directly for this texture. This will only affect the filtering of that particular texture, so none of the other textures will be affected. As you can see, it works. You can't at the moment, I'm not sure it will come later, you can't specify or override this per renderer component. So let's say you have two crates. Okay, let's create two crates. Oh, let's have this at minus 100 and this and plus 100. You can't have this one with nearest filtering and this one with linear filtering, because you change it on the texture basis, not on the renderer component basis. It would be easy to add, so anyone that needs that for some reason can override the sprite and in its render method change the filtering of the texture and then change it back, or just so it's not lost somewhere. If anyone needs that, let me know and I can add it to the sprite itself, but I don't think anyone would want that. So next thing we are going to do, let's think, I'm not sure. We can go and create some animations. I'm not sure we have time for that. Probably I should break this up. I will upload all these, the workspace, oh no, not the workspace, the project of this tutorial to the web as well, so anyone watching this video can grab it and try to play with it. Oh, one more thing I want to add here is, since many people need that and it's not obvious right away, if you want to benchmark stuff, there is this stats rendering stats helper in Genome2D, so you can enable, so you see how fast it's running and other little stuff, how much memory it goes and how many draw calls. Yep, it's here. The draws one is a little misleading. There is a bug, a small bug I didn't fix yet, that if there is exactly one draw call, it will not count correctly, because it tries to subtract one draw call for the stats itself. That's why it's showing 0, and it's obviously drawing stuff, so it shouldn't be 0. There is also extended stats. I don't use these much, but some people do. It will also show you the number of textures, the number of GPU textures that are actually on the GPU, and the number of nodes rendered for each camera. So by default there is one camera in Genome2D that you don't need to know about, but you can add your own camera or even multiple cameras that may overlay and move and render something entirely different. But once you do, you automatically disable the default camera. We will come to this later in another tutorial. Okay, I think that's all for now, and I'm going to upload this to the YouTube, and let's wait for your feedback, guys. Thanks.